In my previous video, I discussed how to find the inverse of a square matrix using the determinant. I wanted to just highlight another option, which is totally viable, and it is something that you can use if you prefer not to use the determinant to find the inverse of a matrix. So let's start with the same matrices that we discussed in our previous lesson. And so if we're looking at finding the inverse of this 2 by 2 matrix here, let's start with this one right here. And instead of using the determinant, what we're effectively going to do is we're going to create an adjoint matrix and just use Gauss-Jordan. And this is a method that's great for students who don't want to learn anything new or don't want to create a new process for this for themselves and just kind of rely on what they already know how to do, which is how to use row operations and get a system into RREF. So what I'm going to do is I'm going to just create this matrix here. I'm going to say, all right, so let's go and write this as 2, -1, -3, +1. And on the right side, what's going to be enjoined is a matrix that is already in RREF, or reduced row echelon form. So it's going to look like this. And I'm just going to go ahead and actually just make that a little bit smaller so I have some space to work with. Okay. So what you're effectively going to do now is you're going to do a set of row operations to try to get this matrix here, this matrix here, into RREF. And in the process of doing these row operations, you're going to end up transforming these values. And that matrix that results there is going to be your inverse matrix. So let's do that. So I'm going to leave that first row alone just for the time being, just because I don't think I need to do anything to it just yet, but I am going to go ahead and adjust this second row or transform that. And so I'm going to say 3 times row 1 plus 2 times row 2. I'm just doing our basic row operations. And I'm just going to write the scratch work off to the side just so I don't make any mistakes. And I might, but it's okay because I'm human. All right, so if we multiply the first row by 3, that gives me 6, -3, and then the values on the other side will become, what is that going to be? That's going to be 3 and then 0. If I multiply my second row by 2, that gives me -6, +2, and then 0 and +2. Now, when I add these up, right, this is just scratch work, so I'm not really too concerned about the notation. My result, and I'm just going to write the result here, should be 0, -1, 3, and 2. You'll notice that these values here on this side of the matrix changed. So we're getting closer to writing this as an inverse matrix. Now, I should note that I have a -1 here, so I'm going to actually multiply this entire matrix here by negative, or the entire row, I should say, by -1. So that's going to multiply the -1, and that's going to change this to +1, and changes these values to -3 and -2. All right, I'm going to erase my scratch work here because I'm now ready to continue on. So I'm going to go ahead and move over here and just draw that arrow to indicate what's going on. So I'm going to copy down my final row. That's good. I don't think I need to do anything to that. And now in my first row, well, I can just go ahead and add row 1 and row 2. So row 1 plus row 2. And that should give me 2, 0. This should give me -2 and then -2. And since I have a 2 in each term, I can go ahead and divide everything by 2. Let me just change that arrow a little bit just to give me a little bit more space to work with. So dividing everything by 2, I write that as my row operation is multiplying by 1/2. And again, the result of my row operation is what should follow. So I'm going to go ahead and change all of these now to 1s because I'm dividing everything by 1. So you'll notice that I went ahead and did Gauss-Jordan to my system. And what results here, that is my inverse matrix. So I can say A inverse is the following matrix. Oops, not A inverse is -1, -1, -3, -2. And if you check that with what we got in our previous lesson, you should see that we got the same exact inverse. So we're pretty sure we did that right. And the process here is just using Gauss-Jordan elimination to do that. So if we compare that with what we just learned previously about how to find the inverse using the determinant, you may or may not have some opinion on which method you prefer. But let me go ahead and do the same problem that we did. So I'm going to take this matrix here, and this again is from our previous lesson. So I'm going to go ahead and take the same matrix, and I'm going to use Gauss-Jordan here to find the inverse of this matrix this way. Okay, so first thing I'm going to do is I'm going to write this as in matrix form. So I'm going to write this as 2, -1, 4, 0, 1, 3, it's, and so on. And then do my augmented adjoint part right here. So 1, 0, 0. Okay. So now that I have my matrix, I'm going to begin my row operations. All right. So the first thing I'm going to do, and let me just follow this underneath, I'm going to leave my row 1 alone. I don't think I need to do anything to that just yet. And my row 2 is actually pretty good too, because it has 0 in the x column or in the for the x term. So I'm going to leave that alone. So the only thing I want to start doing is changing that row 3. So we're going to say 3 times row 1 minus 2 times row 3. Okay, and you can do the scratch work on the side, but I think I can do this mentally. That should give me 0 if I did that right. And this should give me positive 1, 10, 3, 0, negative 2. All right, so now that we have that, moving on to my second, we got 2, negative 1, 4. Again, my first 2 rows look good so far. All I'm trying to do is get into REF to start. But now I'm going to go ahead and eliminate that 1, so I can say, might be easier to actually subtract row 2 from row 3. So we're going to say negative row 2 plus positive row 3, and that should give me 7, and that should be 3, and negative 1, and then negative 2. And to get that row 3 with a leading coefficient of 1, I'm going to divide everything by 7 now. So there's negative 1/7. Oh, sorry. So um, that should give me 3 plus negative row 3. Oh, I'm sorry. Initially, this should have given me negative 1. So to get everything with a leading coefficient with 1, so I'm now going to divide everything by negative 7. There we go. All right. So if I divide everything that's going to give me positive 1. This becomes 3/7. Um, this one should be 7, 7. Okay, pretty sure that's right. I may have made a mistake earlier. I apologize for that. So hopefully I've adjusted that now. Okay, so now I'm in REF. So I'm ready now to go ahead and start eliminating these. What I'm going to try to eliminate are these terms, make those zeros. Okay, so that's my goal. So I'm going to bring down my third row since that is locked in. I don't need to do anything else to that. But I'm going to now go, let's see here. Let's go ahead and do negative 3 times row 3. Let's go negative 3 times row 3 and add that to row 2. So that should give me 0, 1, 0. And that should give me then negative 9/7, positive 3. Oh, sorry, that would be a positive 3 plus 7/7, so that's 10/7. And then we're going to go negative 3 times negative 3, and then that should give me 6/7. So you're starting to notice, yes, I am indeed getting some fractions here. So I should have probably given you a trigger warning here. It is going to get a little gnarly, but I promise you it will be fine. It'll all work out. Okay. All right. So now finally we need to, well, not finally, we actually also now want to get rid of that 4 or eliminate that 4 in the third column. So we're going to go negative 4 times row 3 plus row 1. And that should give me 2, negative 1. Those aren't going to change. This becomes a 0. And now let's see, that's going to give me negative 12 plus 7. So that's negative 5/7, 4/7, and 8/7. Pretty sure that's right. Okay, hopefully that's right. All right, we're pretty close. Okay, all that we need to do now is to eliminate this term and make that 2 here become a 1. So we'll take care of that in a second. So let's copy down everything from rows 2 and 3. Those aren't going to change. Those are locked in. So 10/7, 6/7, 3/7. All right. So now I can easily eliminate that negative 1 by just adding row 1 and row 2. So let's go row 1 plus row 2. So when I do that, that gives me 2, 0, 0, and that's negative 14/7. So that's just going to be negative 2. 4/7 plus 10/7 gives me 14/7, which is positive 2. And again, another 14/7, which is positive 2. So again, I notice I've got a 2 in each term, so I'm going to go ahead and divide everything by 2, which I'm going to write as multiplying by 1/2. And similarly, I'm just going to change all of these down to 1s. So I now have my left side in reduced row echelon form. What I have here on my right side, this here is going to represent my inverse matrix. So I will just write my inverse matrix is the following: -1, 1, 1. Apologize for my handwriting. And there we go. There's my inverse matrix. And again, that should be the same thing that we got from the previous problem, but now we are just using Gauss-Jordan to find our inverse matrix.